Hello everyone, I'm Fernando Benitez from the SwissText also, and we have a large title, and it's just about how to get a name in another language, and what can happen, what can go wrong, and it's mostly about also how can you track someone, for example, on Twitter, and noise data, where not only from the process from change the language, there will be some missing accents or just really very different transliteration, like also the end of the word will change completely, and if there are no password available, the guy can use any possible name. I will show you in the post. Thank you.
My name is Johannes Garland. I'm from the Computational Linguistics group at the University of Zurich, and we are presenting our multilingual tokenizer. The tokenization is often not considered an interesting problem, so we just want it to work. It should be easy, no? There are some white spaces and then you cut the words, and apparently it's a lot more difficult than that, and we found that most problems, the majority of problems in our NLP pipelines come from errors in tokenization. And furthermore, a big problem appears when you just reuse a tokenizer that works perfectly on some kind of material, say being trained on newspaper text, and you apply it to a different text type, like biomedical text. It just won't work that easily, and tokenizers are usually not so easy to adapt. That's why we built our own tokenizer, which is modular, which can handle any language that you provide rules for, and it works in a test-driven way, so you define how your corpus material needs to be tokenized, and can prove that when it works on all your tests, that these text type is covered.
So, hi everybody, my name is Samuel Bones, and I'm one of the representatives of the Centrometrics research project. So this is a joint project between the University of Neuchâtel and University of Brussels in Belgium, and essentially what we try to do is we try to merge text mining with econometrics, and more specifically we apply time series econometrics on sentiment values. So what we do is we aggregate sentiment values into time series. We think about how to model these time series to represent some kind of information and to use that for prediction and forecasting purposes. And one of the main realizations of this still very young research project is an R software package in which we propose a generic framework to deal with this merging of sentiment analysis with time series econometrics. We have nice results concerning macroeconomic forecasting, and also we are working on application in reputation monitoring, and this is what this poster deals with. So come have a chat with me or with David, who's also here. Thank you.
Hi, I'm Noemi from the Computational Linguistics Department at the University of Zurich. We have been working on a manually annotated part of speech corpus for Swiss German dialects. We present here recent improvements that we have achieved using machine learning techniques, and also one application naming parsing, so the automatic grammar analysis of Swiss German sentences that we have done using this corpus.
So my poster is work that students at the University of Zurich did in the last years, providing morphological analysis for Romansh Krishun and also in part for some of the idioms. But what I present here is a more systematic overview and a large resource, several thousand verbs, nouns and adjectives. So if you happen to be interested in dealing with written Romansh text, law texts are there. It's not spoken actually, but written texts are there. If you want to analyze them, we have finite state tools that are very efficient that can generate and analyze things. And we have built an annotated data set. It's only 8,000 tokens, but we achieve quite a good performance in part of speech tagging, not only coarse-grained part of speech, but also morphological text. So maybe you want to build a chatbot or error correction for Romansh Krishun. We have some data and we are willing to share these things. Thanks.
Hello everyone, I'm Pius from Spinning Bytes, and a co-worker of mine, Ralph, who should be somewhere in the crowd, he recently collected a corpus from Swiss German-speaking fora on the internet, and we then noticed that there is quite a lot of non-Swiss German text still in there. So that's kind of sparked the idea that we need actually better Swiss German language detection tools. So we kind of try different methods of for Swiss German language detection. So one is just binary classification, Swiss German, not Swiss German. We also try one-class classification. The idea is to be maybe a bit more robust against all kinds of languages, because usually if you do just a binary thing, you probably don't cover all your non-Swiss German class. And we also try language modeling. And yeah, we're mainly interested actually in high precision language detection, just because at some point we want just to have a good crawler that gathers Swiss German phrases. So if you don't catch everything, it's okay, but at least what we catch should actually be Swiss German. That's the goal. So yeah, that's.
Hello everybody, I'm Ali Reza from MK Informatik, and at MK, among many other problems, we are working on a lesser known task of natural language processing called stylometry, which involves the problem of detecting whether two pieces of text are written by the same person or not, and also inferring demographics and other characteristics of text, such as the native language of the speaker or the gender or the age range. And as part of our effort, we have collected a data set from Swiss news website containing author tags as well as content tags, so that one can more easily separate these two factors and provide with more accurate authorship attribution and the stylometric information extraction services. So we would like to share our information and discuss more. If you are interested, we can discuss at our poster. Thank you very much.
Hello everyone, my name is Stian Hochlev. I'm from EPFL in Lausanne. I'm working in the digital learning lab, and we're interested in students collaborating, writing in Google Docs, Etherpad, these things. There's been some research on analyzing the data from collaborative writing. It's generally been very coarse because they've not had access really to the underlying data from Google Docs. Or what we're able to do is, so we have an open source tool that will take the raw log data from Etherpad or ShareDB and normalize it. And then we construct from the fact that you press A, we can now say, okay, did you press A as editing a word, or was that part of writing a sentence? And so there's configurable cutoffs. What is one editing operations? Do you move somewhere else, or do you take a pause of more than 10 seconds, so on? So we get these higher level operations. And of course, as we move through the document history, we can start annotating each higher level operation with metadata, such as Stian wrote a sentence at 3 o'clock. Stian wrote a sentence in a paragraph authored by Pierre. He wrote it while Pierre was at another part of the document, and so on, so on. And then we start having very interesting features that we can hopefully use. And so this is very early work. We have this open source tool that might be useful if you're interested in any of this kind of work. We have some very, very early findings, but we are looking forwards to, and I would love to talk to anyone who's interested in stuff in terms of detecting roles. So who is editing, who is adding new information, how that changes over time, detecting which phase of a writing process students are in, and then of course adding semantics and seeing both if two people are writing, we can extract exactly the pieces written by one student and exactly the pieces written by another, even though it's all smushed together, and see are those pieces semantically different? And is there a change there where, for example, they start out being semantically different and there's a convergence over time or not? And finally, we have an online learning platform that has built-in support for very flexible collaborative writing, and this will actually enable us to, once we have some of these findings, to integrate them into the system, to have an adaptive collaborative writing system, to have live dashboards for teachers and stuff like that. Thank you very much.
Hello, I'm Garland, University of Göttingen. Our poster is motivated by empirical aesthetics research, so it's a digital humanities project, which is actually just about to start. So our corpus is a corpus of reviews, but it's not really about product reviews, but reviews about books that people have read. And so the genre is this one of the complicated genres of user-generated content. There is the Goodreads site where everyone can put up how they liked a certain book that they were reading. And then, of course, it's large quantities of user reviews. We're dealing with English. And you want to kind of extract claims, why. So it's beyond this typical sentiment analysis task. It's not just people liked some book or not, but also why exactly. And my Swiss colleague at the University of Bern, she has a questionnaire that she usually evaluates with people. They have to answer questions like, did they feel that time passed very quick when they were reading a certain book, or that they felt sympathy for a certain character, and so on. But of course, what we want to do is to automatically match these statements about transportation or feeling with the main character, automatically match those statements from the questionnaire to this large amount of text from Goodreads. And for that, we just our initial idea was to use two fairly well-established text mining software. One is the Excitement Open platform, which is textual entailment, and the other is text reuse. So more about this at my poster. Thank you.
Hi everyone, I'm Christoforos from Steam Bytes, and today I'll present you the Swiss Twitter corpus. So the Swiss Twitter corpus is a continuously collected compilation of tweets related to Switzerland. So far, since January of 2018, we've collected more than 3 million tweets related to Switzerland. And in this poster, you will have the opportunity to find out our two-tier approach, the architecture of the system. And also, you will find out how we collected the tweets and how we tackled the problem of defining a Swissness. So a tweet can be defined as Swiss, either if it comes from Switzerland, or if the writer is a Swiss Twitter user. and some other cases. Also, this dynamically growing corpus, it can have numerous applications. In this course, I will present 3 different examples. One is around the development of no black vote. Another one is around which canton is the happiest one. And there's another one regarding geographic tweet distribution around Switzerland. So today I invite you to come and discover even more use cases and explore our current implementation. Thank you very much.
Hello, I'm Inger. Our poster presents a stack of technologies and applications developed at Speech AG. The company has been established in Zurich since 2015. From the beginning, we focused on development of a large vocabulary speech recognition system for Swiss German, trying to cover the main groups of dialects in the country. At the later stage, we added other European languages to our engine, including French with Swiss accent. We expanded our technology portfolio with voice biometrics, doing speaker verification and speaker identification. Both systems are language dependent and text independent. And then to process the results of speech recognition, to process the recognition output for speech utterances, we implemented semantic classifier and sentiment analysis on conversational texts. So for current applications we work on at Speech, we cover IVR systems for large call centers in banking and insurance. We developed voice search platform for mainly for e-commerce and also public transport. We worked on automatic subtitling for weather forecasts for Swiss TV, and we do speech analytics, mainly for data compliance and marketing. So for live demos and for the poster presentation, you can visit our booth in the main hall. Thank you.
Hi everyone, my name is Alex. I'm from the company Contexity. One of the areas in which our company is active is implementing tailored search solutions for our customers. And in that context, we're very often confronted with the challenge of extracting structure out of free-form text. A very characteristic example of that being product descriptions and thus being extracting characteristics of the products directly out of the descriptions. And in our poster today, we would like to show you, and a demo we have prepared because we would like to show you some of these techniques that we actually use and real implementations of search portals that put them into practice. So if you are interested in these topics or have questions, we would love to see you at the poster. Thank you.
Hi everybody, my name is Aaron. I'm from Turicode. Turicode is a ETH startup active in the area of data extraction from documents. So basically the input is a PDF document or an image and the output is some structured representation, being it text, XML, a database or JSON. And the work we present here on our poster today is a pre-processing step that could be useful for text analysis. And we present a pixel-based classifier for documents. sometimes it's not possible to distinguish, for example, a paragraph from an image caption only by the text value, but we need the graphical representation in order to decide whether it's a paragraph or an image caption. And if your system doesn't want to include the image captions, then it's necessary to classify the text elements in a document. And that's exactly what we did with our deep learning system. We classify various elements, being it images, tables, captions, normal text paragraphs, titles, etc., and can then specifically extract only those elements which are of interest for later analysis.
Hello, I'm Fabio Rinaldi, the Computational Linguistics in University of Zurich. And this poster is about information extraction from biomedical text, which includes the scientific literature, electronic health records, and online discussions. For example, patients' online discussion, blogs, and tweets. And in my group, we have several projects that deal with this type of text, extraction of information, extraction of entities, and interactions from this type of text. And in 1 minute, there is not so much more that I can say, so I invite you to come to my poster and see what we do with these different sources and how we process the text and get information out of it. Thank you.
Hello. We all know that Swiss people write parkieren, while in German High German this would be parken. But could we perhaps come up with a more systematic survey, completely based on the data? Yes, we can. We observe differences at the level of lexis, morphosyntax, and syntax, and as approaches we use document classification, automatic tagging, and parsing. At the level of lexis, for example, here ordered by descending feature influence, you see welch, which is underused, it's more often der in German High German. Zürcher would be Züricher, Basler would be Basler. Gemäß is used a bit less because Germans often say zufolge typically. They don't say Anlass, but much more often Veranstaltung. And this list contains thousands more entries. At the level of syntax, we see that German High German has longer sentences, more genitive modification, and is a bit more synthetic than Swiss German. We could even see indications that perhaps the Swiss are less direct. Do you want to know more? Well, bei allfälligem Verlangen nach mehr Information ist das Poster an diesem Anlass zu besuchen. Zwecks Stillung aus etwa einem Informationsbedürfnisses bitten wir zeitnahes Aufsuchen der Poster dieser Veranstaltung.
Good afternoon, everyone. My name is Christoph Knaber from Slowsoft. Slowsoft is a company that provides speech technology components, that is speech recognition, speech dialogue, and speech output, text-to-speech for minority languages, basically the Swiss minority languages, Swiss German and Romansh. We are actually the first company to provide TTS for these languages. For speech recognition in Swiss German, we work together with Speech, for example. You have heard Igor before. Text analysis is an integral and very important part of each TTS system, and the focus is on TTS in this poster. It will show the role and the importance of text analysis for a text-to-speech system. And it will also provide solutions or envisaged solutions that we have found for the problem of dealing with text input for Swiss German. You know all that Swiss German has no standardized textual representation. And of course we will also have some demos or links to demonstrations.
Hello again, this is my poster. I will talk about compound splitting for German and Swiss German. So you probably know that in German we build compounds without inserting white spaces between the constituents, which is very annoying for natural language processing. For example, if you have a compound like Rindfleischetikettierungsüberwachungsgesetz, which actually exists. You probably don't have word embedding for that, and if you want to do NLP with this word, you need to find some more frequent representation for maybe Überwachungsgesetz or even Gesetz as a representative for this word. So that's the problem of compound splitting, and for this poster we evaluated several neural architectures, sequence models from deep learning area and compared them to some state-of-the-art baselines. And also applied these to Swiss-German compound words. So we annotated around 150 Swiss-German compounds and compared the different approaches to compound splitting on this data.
Hello, my name is Garland from the Swiss Distance University of Applied Sciences. What we did is the following. We had a text divided in three parts, a neutral, a negative and a positive part, and we analyzed this text with a word list, the Berlin affective word list, on the valence, that means on the positive, negative connotations of these words, and divided it by the section of this text. That can you see on the red line. So what you see good, the positive text has a more positive emotional content as it should be. The other ones don't divide. And then we wanted to know if readers really feel or express what they read, the emotional content that they read. And we filmed 91 students during reading this text and analyzed these videos with software that recognizes emotions on the face based on the movements of the muscles. And this is represented on the blue line. At the first sight, there's no big matching. If you look very, very good, then you find some, if the red line text goes up, sometimes the line goes up as well. And statistically, it is significant. But it explains less than 1% of the variation. So for the moment, we think readers don't show the emotions that they read and don't mirror what they read. And we have to look for other analysis to get a better result.